For the rest of the chapter, we're going to be talking about some properties of gases. One property is diffusion. Molecules of gases are going to move from areas of high concentration of that particular gas to areas of low concentration of that gas. Let's say we start with two gases, hydrogen and oxygen, and they're separated from each other with a stopcock. Then we open it up and allow them to start mixing together. The random motion of the molecules is going to cause them to move, and they're going to start moving into each other's territory, if you will. Eventually, they're going to end up with equal concentrations on both sides of the container. So there will be an equal amount of the hydrogen on each side, and there will be an equal amount of the oxygen on each side. The end result for both gases is basically the same, but the rate of diffusion depends on the mass of the gas. The rate of diffusion is measured as the amount of gas passing through a particular area in a given amount of time. The lighter the gas, the faster it's going to diffuse. Hydrogen is going to go through much more quickly than the oxygen will. So if we look at the colored dots, the hydrogen is the white, and when the stopcock first opens, there's actually quite a bit of white getting over to the other side, but not all that much red because the oxygen is diffusing more slowly. But eventually the red does get through. Another property of gases is effusion. Effusion is escape of gas molecules through a tiny hole, like a pinhole in a balloon, into a vacuum. Effusion and escape both start with E, so that's one way to remember it. With diffusion, gases are spreading around a container. With effusion, they're starting in a container and leaving through a tiny opening. They escape one molecule at a time, so it's a really, really tiny hole. Graham's law of effusion, which I won't make you use in calculations, says the rate of effusion is inversely proportional to the square root of the mass of its particles. In other words, the heavier the molecule, the more slowly it will effuse, but lighter molecules will effuse more quickly. This mass-speed relationship is similar to diffusion. In both cases, the heavier gas is going to be more slow, and the lighter gas is going to be faster. However, they're coming from two different principles. Two different effects are happening, and they have two different equations that apply to them. If we look at a pair of balloons, one is filled with helium and the other is filled with nitrogen. The gases can escape through tiny holes in the latex of the balloon. The helium is going to escape more quickly because it's smaller, so when it's heading toward the hole, it's more likely to align with the opening and be able to pass through. On the other hand, the nitrogen, being bigger, is more likely to bump into the edge of the hole and end up going back inside. Effusion is based on the relative size of the molecule compared to the size of the hole. The helium escapes faster because it's smaller, and the nitrogen escapes more slowly because it's larger.